And as an example, I'm gonna solve problem 1-3. Here we have two vectors, v1 and v2. We know the angle of each of them, we know the direction of them, and also we know the magnitude of them. v1 is 12, v2 is 15. We want to find v1 plus v2 as scalars, v1 plus v2 as vectors, v1 minus v2, v1 cross v2, etc. Right? I'm going to do just a few of them for you, just to show you how it works. So to calculate all of these, probably the best strategy is writing both of these as vectors, then add them together, subtract them, do dot product or cross product. So v1 is going to be equal to the x component of this vector is going to be 12 times cosine of 30, and the y component of it is going to be 12 times sine of 30. So I can write it as 12 times cosine of 30 in the I direction plus sine of 30 in the j direction. Or if you calculate those sine and cosines and multiply 12 to it, it's going to be 10.39 in I direction or x direction plus 6 in the j direction. So it doesn't have any units, so I'm not going to write any units here. So v2 is going to be equal to, the magnitude of v2 is 15. So to find the x component, I need to multiply to the cosine of this angle. So if you look this symbol, this triangle, this is 3, this is 4, and the other side is going to be 5, right? So cosine of this angle is going to be 3 divided by 5. So x component of this vector is going to be 15 times 3 divided by 5 in the negative I direction. So I'm going to have negative 15 times 3/5 in the I direction. And in the same way, 15 times sine of this angle, which is going to be 4 divided by 5. And it is in the positive j direction. So I'm going to have plus 15 times 4 divided by 5 in the j direction. So it's going to be equal to negative 9 in the I direction plus 12 in the j direction. Now, after writing them in vector forms, now I can do all of those calculations. For example, v1 plus v2. If I want to add these two vectors together, I need to add the I components together and also the j components together. So the I component is going to be 10.39 minus 9. So it's going to be 1.392 in the I direction. And the j component is going to be 6 plus 12. So it's going to be 18 in the j direction. And in the same way, you can do subtraction and the rest of it. In one part of it, it is asking what is v1 plus v2. And if you look at the question, v1 and v2, they are not bold, or they don't have any symbol for the vector. So this means the magnitude of v1 plus magnitude of v2. So two scalars. So it's going to be just simply 12 plus 15 or 27. Okay? Because we don't have any vector symbol here. And if you want to do cross product in the same way, v1 cross v2, for example, it's going to be 10.39 in the I direction plus 6 times j, and cross product to negative 9 in the I direction plus 12j. So just to remind you, always look at this. This schematic, this figure. So when you are doing cross product between these unit vectors, you can actually figure it out from this without even thinking. I cross j is k, j cross k is I, k cross I is j. And if you go in the opposite direction, it's going to be negative. For example, I cross k is going to be negative j, etc. So here we have, first we have I cross I, which is 0. cross product of two parallel vectors is 0. So I cross I is going to be 0. Then we have I cross j is going to be k. So I'm going to have 10.39 times 12 in the k direction. Then we have j cross I. J cross I is going to be negative k. And we have a negative here, so positive. So I'm going to have 6 times 9 in the positive k direction. Then k cross j is, j cross j is just 0, two parallel vectors. So if you calculate the numbers, v1 cross v2 is going to be 178.7 in the k direction. And let's do another one. What is v1 dot product to v2? We should know it's equal to v2 dot product to v1, right? In dot product, you can change the order, it doesn't matter. So v1 dot product to v2, v1 is 10.39 in the I direction plus 6 in the j direction, dot product to negative 9 in the I direction plus 12 in the j direction. Now we need to do dot products one by one. I dot I is 1, so I'm gonna have negative 9 times 10.39. Then I dot j is 0. Dot product of two perpendicular vectors is 0. Then j dot I is 0 again, and j dot j is 1. So I'm gonna have 6 times 12 from here. And this is a dot product, so the result is gonna be just a scalar, right? So if you calculate these numbers, this is gonna be equal to negative 21.5. These are the results.